Okay, so I press record. Afternoon, Jeff. I'm at work, Matt, and our company firewall has a block on that website.
Okay.
Do you want to do introductions, please?
Hi, Caleb. Or how do you pronounce your name?
My
Yeah.
name, it is a bit difficult actually. It's yeah, let's just try Chouaib.
Is it up on software source or something? I didn't know you
Hey, Sohin.
Hey, hey everyone.
Oh, we've got a special guest today. I don't know if you saw the post that Matt put. Again, I apologize if I'm mispronouncing it, but Chouaib, is that pretty decent?
That's just perfect.
Awesome, thank you. Dr. Chouaib, I think.
Yeah.
Which is fantastic. Way to go. Congratulations on that.
Thank you.
He's with the Center for Precision Agriculture, and the website precisionag.no is out there in the Slack channel. So I spent a little bit of time on it, and it was looked like some super cool stuff. I want to dig into all the details of how they got all that going, but happy to have you here today. Generally speaking, we use this time to talk about a specific project that we had initiated. Those of us that were interested in focusing in on trying to get a lawn tractor converted to be a ROS-enabled machine. The notion behind that was, hey, if we all had one particular platform that we could focus on, then maybe we could solve some of our problems and then move on from there to other use cases that we all had in the back of our mind. So it's not like all of us had this particular use case in mind. It's really a platform that we thought would be doable, and then we could move from there into more complicated things. So, but why don't you tell us a little bit about yourself and precisionag.no, and we'll take it from there.
Sure. Can I share screen or something, or?
You can. There's going to be a box at the bottom of the screen with an arrow pointing out of it, and it looks like you've got that going.
Yeah. Okay. So yeah, my name is Chouaib. My name is a bit longer than this actually, but I can just keep it at Chouaib. That's easier. I'm a postdoc research fellow at the Norwegian Institute for Bioeconomy, which is in Norway. We're an institute that is located all over Norway with different research stations, and we are located just 2 hours north from Oslo, in a place that is called Appelsvoll. My group is the Center for Precision Agriculture. So just to make it short, what is precision agriculture is we usually what is going on now in agriculture. Usually when you have a field and you want to apply something on the field, so you just go and do it on uniformly. So you just apply the same treatment on all over the field. Now it's a bit going a bit advanced. It's site specific. It means we get information from satellite data, and then we define where the plants or specific places on the field that needs different treatments. And now we have a bit more accuracy, which is the level that we are dealing with in our Center for Precision Agriculture. We have our own UAVs, so we have multi-spectral cameras that we just having flights on the field, and then we define, we have some agronomical models where we define where we need to apply, for example, nitrogen on the fields, because different plants or the plants does not need the same amount, so they need different amounts. So this will save actually the input of the field. So we just like go and spray on specific locations. And to do this, of course, we have different sensory information, as I mentioned. So satellite data, UAVs, handheld measurements, some robotic stuff, and some sensors that are mounted on the tractors. And the outputs of these sensors are just like, this is an example on, this is our station, and these are pictures, some examples of the outputs of the sensors. So we can have like hyperspectral images that we can define. From these images, we can define the biomass, we can define the crop height, the N content, the temperature, the weed detection, water stress, and so on. So the different areas that we are working on at our Center for Precision Agriculture. So we have precision weeding, fertilization, data handling. So we do both collect data and handling data. And then the part that I'm working on mainly is the robotization and automation. For this part, I'm working on both indoor and outdoor navigation. Actually, I'm working on ROS mainly. So I'm developing some navigation stuff for indoor and outdoor GPS denied navigation and outdoor navigation. And one of the projects that we are working on, I'm just like skipping the slides so it won't be too long. One of the projects that we're working on is called Solar Farm, which is mainly using like solar panels to produce electricity, to be used for machinery inside the field. So the idea is to replace the fossil fuel-based tractors with electrical ones. So we have now an electrical tractor that we bought from California, local producer, and we have like a big robot as well that I'm going to show a video briefly of it. And then the idea is, of course, to produce the electricity on the farm and use it for this machinery. One of the main goals of the project is to have fleet management. It means like we want to go with the regulation. It means like we need to have a pilot or an operator present at all time inside the field. So the idea is to use like a small electrical tractor and having like multiple robots that are following the tractor autonomously. And this is what I've been working on lately. I began with just visual steering. So there was like just QR code on the tractor, and the robot follows this. But now it's I ditched this because it's mostly unusable inside real fields because you have a lot of dust and weather conditions and so on. So you cannot rely on the visual data. So now what I'm working on is the communication based. It means that I have the master-slave architecture on my RAW. So I have like the tractor as master. I have two computers. I have one that is on the master, on the tractor as a master, and I have one on one robot. And we can extend this to several robots. So the idea is that the robots looks where GPS information of the tractor is, and just try to follow it based on this. So and that's what I'm going to show now is a video that has been taken just a few days ago. I think I have a problem with the codec here. Yeah, it's so slow. But yeah, so that's the robot that we have. It has the same functionality as a normal tractor because it has this free mount point system on the back. So we can use that. Sorry?
Pardon the interruption. We're still on the work packages 1, 2, 3, 4 slide.
Oh yeah, okay. It hasn't changed yet. Have you got the video or?
No, you may have just shared one particular screen instead of shared your desktop.
Oh, okay, yeah, that's true. I need to get back to this. I've never used Zoom. Sorry, I'm a bit.
It's okay. I fight with it all the time too.
Yeah, here I can do a new share and sharing the whole desktop. That's faster, I think. Do you have my whole desktop now?
I believe so, yes.
Yeah, okay. So yeah, that's the video. It is slow. That's the research station. Will have an incredible view, and
Fantastic.
that's the electrical tractor that we have. Both of them have RTK GPS antenna. So we have an RTK base station that is not far from here. We will see it when we go around. Yeah, as I said, like I have problem with the codec of the video, but I will just like have snaps. So here we can see this this robot that has like 3-point system that we can use like any anything that can be mounted on a normal tractor can be mounted on this robot. It has lift capacity of 750 kilograms. I don't know the other. I'm just usual with metric values. I'm sorry, I don't know the US. So yeah, so this 750 kilograms, both of them are electrical vehicles. So what we are doing here basically is we have computer here. I created or I made like this black box that has like an NVIDIA Jetson board that is run ROS and linked to the antenna here, and then that's the RTK base station. And then there is communication between these two. So there's local AP Wi-Fi network, and of course I have as well 4G on the tractor. So this robot is connected to the tractor network and gets a full time continuously the GPS information of the tractor and just try to follow it. Here we can choose the mode of following. Actually, we can follow whether on back. So we have two modes: follow back or follow on side. Follow on side is most useful inside the field because you don't want the robot to be behind you. It's useless. So the best is to be on side. And the follow back is useful when we are driving back into the field. So when you're on, like, for example, this kind of roads, so you need the robot to follow behind you, not beside you. And then once you're inside, you just like switch the modes. So that's the actual state, but I'm working on including second GPS antenna because I cannot rely on the IMU for the heading. I have I had troubles with the IMU, only the IMU. So what I'm doing now, actually, I'm not using the IMU at all for the heading. I'm just like, I have one antenna and I'm just reading like successive information from the GPS and then like defining the heading from two successive points of the GPS. So the problem with this is that when you're on stationary position, so you have like just jumps and you have like random heading. So I'm going to include second GPS antenna to have like the heading based. I know the distance between the two, and of course I will be able to have the heading, and I will include as well like a high precise IMU. It's the VN 100, the VectorNav 100. I will include it as well. So. But I have like some other project that's going on side of this. So this was just, I think, 1 week or 10 days ago. So that's the latest actual status of what we are doing. And to be on the line with the more project, we have in mind to optimize like to make this tractor autonomous as well. So we will need like to change, because this is an old tractor, like old body, but it's electrical, so it has like some batteries inside and so on, but there is no logic, no steering, nothing, so everything is really manual, like the hard style. So we need to think about how to make it autonomous as well, because we want to acquire other vehicles and so on, so we have like a fleet that works at the same time. So yeah, I think that was a quick hopefully introduction of what we are doing and an example of what we are working on. So if you have any questions, you can just ask me.
It looks like a great facility, and the view was awesome. I kept looking at the, other than I wasn't concentrating on the tractor all the time, honestly. But I was wondering if you're using ROS one. I believe so.
Mhm.
Uh,
Yeah, I am using ROS 1. I haven't migrated to ROS 2 yet because the thing is, like, we're a project-driven institute. We're not funded 100% from the state, just 30%, 70% are on the project. So we have like deadlines and so on. So for now, I need something that works, and I'm familiar with it. Of course, ROS 2 works as well, but I'm not familiar with it, so I don't have enough time to migrate for now. I think I will do it during the winter, try to take a look at it, because in Norway, winter, you cannot drive outside, so mostly. So it will be like the development time and looking for on other stuff than doing the navigation outside.
Yeah, I think it was this past Tuesday, at our other Ross Agriculture meeting, we had Joe Speed and the CEO, I believe, of uh, what was the robot company? I forget, but Matt can Matt knows properly.
Those rover robotics.
Rover robotics, exactly. But they have a nice they they've written some documentation about if ROS2's you know uh, doable at this point, and I think the general consensus is that it's not there yet. It's still not there yet for
Yeah.
something that's as robust as what we're trying to achieve here.
Okay. Yeah. I
Yeah.
think
No.
for now.
The question just came to my mind because you mentioned fleets, and ROS2 is, directed towards working with fleets with the DDS implementations. So there might be a
Now
performance
we just doing like
upgrade.
really the simple stuff. Like we have ROS master that is running. The other robot is just like subscribing to the topics of the master, and then that's all. As long as you have like robust Wi-Fi connection, you're ready to go. But if you lose connection, then you start to have some troubles. So, but for now, it's just like as basic, and it's working like really well. So.
Yeah, this was it looked really nice, and the thing was following it. So yeah, kudos on that.
So what's the biggest challenge you're working on now?
Actually, I had the problem because the landscape I need to be the Norwegian landscape. We don't have flat fields as in the United States, like really huge flat fields. So you need to compensate for the orientation of the tractor or the robot inside the field, because if you have the GPS that is flat and you have the information, it's not a problem. But if you have the GPS that is inclined, of course you will need to compensate this because you don't have like a real position. So yeah, it's shifted. So you need to do this at all times with the IMU. But I already have, because one of the architecture that I'm using on the robot is that I have BigSock that is installed there, just like for the remote control, and one of the GPSs and some IMU inside. But the problem is like the robot is like a big metallic box that is really generating a lot of interferences for the IMU. So that's why like I'm just based for the heading on the GPS. I'm not using the IMU because you really see that like how the IMU, the heading is changing, even like if you're in static position. So I need to find a way to like have because I was calibrating the heading of the IMU at all times based on the GPS, and then I just like ditch it out. I just said like it's a lot of interferences, so I cannot like just rely on the IMU at all time for the heading. I'm just using the GPS, and now I will need to integrate the position of the robot or the tractor inside as well, to have like really precise GPS coordinates, because when you're inside the field you don't want to damage the crops, and you need to have like really like precise navigation inside. So that was one of of the things, and as well, like I have a lidar on the robot, and the lidar rain dust is not the best combination. So I'm just thinking I'll most likely include other sensors as well, like for the security stuff.
Okay, yeah, heading is a big issue. Have you seen that F9P little $200 L1, L2 GPS?
No, I'm using a Pixie Swift the Pixie Swift GPS now, and then the GPS is really good. I have like because I have the RTK base station, so I have really good positioning, and the heading is good as well with what I have now.
Okay.
And I use as well like the VectorNav IMU, and when I'm doing the tests on my desktop, no interferences, no problem. But once on the robot, it starts to get crazy. So I need to. This is one of the problems. But because I was looking for the thing is like on all my robots, I use I really don't rely much on the available packages for pose estimation and navigation. I do my own code. It's easier for me because like I don't have odometry on my robot, so I usually like do my sensor fusions and so on myself. And the heading, for example, you don't find much of for example, the heading based on the GPS. Like you don't find available packages, so it's just like a waste of time to just keep off looking. So I just like hard code these things myself. It's not it's not difficult. It's really easy to do, but it's not available, and that's what why I was like interested to join the community, because I'm pretty sure that I was pretty sure that I will find people that have the same problems, same concerns that I'm facing when I'm putting my robots inside the field, because navigating inside and outside it's totally different stuff. So the same thing.
Yeah, it's funny, that heading issue, we talk about that a lot. It's a problem with outdoor robotics. And then the IMU is also difficult. You know, if you want to do a calibration, like on a lot of the drones, when you start them up, you have to do a calibration and move them in 3D. But I don't know how to take a tractor and do the same thing when it's running.
I have 850 kilograms and 2 pounds tractor, so it will be a bit problematic to to calibrate this, because actually we did the calibration of the box before mounting it on the robot, because it just like take the box and do some dances around and so on. It was calibrated, and then like after, I don't know, going around for a few days, he really like start. It's really completely 180 degrees like shift. So it's seriously crazy, because like it has the auto update function inside to calibrate this every time, like tries to calibrate this every time that turns on. So it's just like messing up everything, and it try to make the IMU as far as possible from the metallic frame, but it doesn't help much. So that's why I'm thinking about like, or not thinking, but I started the process of including second GPS antenna to just like, for the heading, just keep it away. And what I've done actually, just to go a bit into details with the heading, I'm using the current and the old position of the GPS to estimate the heading, and then I'm injecting this into like a Kalman, not Kalman filter, but something that is similar, is called double exponential smoothing algorithm. It's DES algorithm that takes like the real value and try to predict giving you the trend value and prediction. So it's like it has two values, and then with this, so if you have, for example, jumps in the GPS reading, so it will just like give you a smooth output. And that's why, like in the beginning, I was not using this, and then you see really like the robot that is dancing like at all time when it's navigating. But using this, you really have like smooth changes. And if you have like some peaks, erroneous like readings, it will just like don't take this in consideration. So
Yeah, I ended up doing the same thing with heading. I would use the GPS for heading, but then I use the TEB local planner. So if I'm backing up, the GPS would still say that I'm going forward. And so I ended up using the IMU when I was using like the velocity message out of the GPS to calculate heading. But when I went backwards, it would flip me around and say I was going the other direction. My heading was going backwards when I was backing up. So I ended up switching over to the IMU if I was going backwards, but then combined that with a ROS package called GPS pose, which just takes the heading and your GPS position. But I had to make a little heading node that would bring in the GPS heading and the IMU heading and then another heading and then kind of switch between those.
Yeah. It's not tribal actually, to especially like for this precise, if you have like precise tasks that you need to do inside the field. You cannot rely 100% on GPS. For example, if we're driving inside the rows, one of the future plans is to include as well like the detection of the rows using the camera and the lidar information to just like see where the rows are, and yeah. So but this is the beginning. It's just like the first year that we began to start driving the thing outside autonomously. Because the story of the robot, we bought it from a company, it was just a prototype, a promising prototype. Then we ended up like just removing everything like and starting up from scratch. Like we changed all the electronics and all the mechanics and so on. So we spent almost a year doing this, and then just this summer that we started like to drive, especially with the GPS and so on. Yeah.
That looks great. It really does look beautiful. What a great proving ground that you have to test the robots. Were you also working on outdoor and indoor navigation, be able to drive the vehicle through?
Indoor navigation is for small robot actually.
Okay.
That can be used for greenhouses, for example. I was using the HectorSlam package for defining where the robot inside, just based on the lidar information. And I as well wrote something for like combining. We've published a paper that is called combining HectorSlam algorithm and potential field for navigation inside the greenhouse. So I used the package that is the HectorSlam, and then like I created something that is based on potential field to make the robot go inside the greenhouse, like between the rows autonomously. So that's where I'm, and then we have a paper that has been published just three days ago on the hidden wave function. It's just like a local planner based on the lidar information, only lidar information. That's why I said like usually when I try to, in the beginning I tried to use the move base package and so on, and I ended up like spending much time trying to configure this, and I have like a robotic background, so I have PhD in robotics, so I can create my own controllers and so on. So I found it easier for me to just like do some math and code it and make it work than to, and it's working fine. So I'm quite happy with it. That's why I said like I work on both indoor and outdoor navigation. But yeah, that's we're part of this project that we're working on now. Includes that the robot or the tractor, when it's autonomous, needs to go from the field, park itself inside the garage, and go outside again. So we will need to switch when we are, for example, close to the building, switch from the outside navigation and switch to inside navigation. And for now, we just thought about something really simple to make this running. There is this ultrasound beacon system that is called MarvelMind that we already used. So you just like put some ultrasound beacons and you have like the heading, and once the robot detects this, it would just switches from the GPS to these beacons, and then just like park itself inside, and then we're going a bit yeah, it's funny thing. We're having like another robot that is omnidirectional robot that it will go and plug the charging cable inside the robot. So that's the concept that we have. Now I just like have shattered pieces of all the stuff. So I have this small robot that can do this, and they have the big robot. But I will arrive to the time to combine all this. But now it's just like several small parts that are being developed separately. So.
Did you say that have you used the AR tags for indoor?
No, the AR tags, I used it once for the outdoor navigation to make the robot follow the tractor. I can show you a video here. Yep, here. And then share the desktop, and then we can find. Yeah, that's the video. Here, that's in winter. Okay, this video does not stop too much, so it's good. Here it's just visual-based navigation. It's really simple stuff. So we have like a camera in front of the robot here, and you will see that there is an R tag when the tractor goes around. That's the same place, but just in winter, which is almost most of the year in Norway. Or, yeah, most of the month is. You will see here in the back. It's coming here.
It seems like it's doing a good job being able to see the tag.
Yeah, we have a big tag actually. And then like a simple controller to do this, like to see where the tag is, and based on the position of the tag, just like give some speed velocities, and the size of the tag defines how far we are from the tractor. So that's an example of. But like as I said, like this thing looks nice. It's smooth. It's following, but it's completely useless in real applications. So yeah, it's just like to show the concept that this is what we wanted to do, because at this stage I didn't had like this leader follower scheme based on communication working yet. So I began with just like this. This is as a first stage, and then like the video that I showed previously, it was the second stage of this. And I can try to find the video of the indoor navigation that I've done. Sorry for taking the time. So it's drill videos, explanations, and into the videos. This so that's the example. Just like to give brief presentation. So that's the small robot that is running as well. I don't have odometry on this. I'm using these beacons for seeing where the robot is inside, but I don't have any prior map, any knowledge of the environment of where the robot, like where the obstacles are and so on. So I just like know the initial position and where the robot needs to go. And then we have the LiDAR on the front. So we just like using this function. So try to navigate through these obstacles and then like go into park inside here. The function is called the heading weight function. It's a weight function. So we have like the LiDAR, which is 180 degrees, and then like we just see where the obstacle is, left side, and the position, close, far, and so on, and then trying to have the weight of the summation of the beams to define how the robot should navigate. And then here is just an example of a dynamic obstacle that goes inside the path of the robot. And then of course we can see that the robot tries to move and adapt, and goes to the parking area and park itself. So that's the LiDAR which is on the front, and I'm using the SICK 571, I think, LiDAR, which is mounted here on the front. So that was another example of the indoor navigation stuff that we're dealing with.
Wow. Awesome.
Yeah, we're having some fun actually. So.
I did have a follow-up question. I'm super curious about using ROS in a greenhouse for controlling everything.
Yeah, but we're having like in my team having like several people who are working on several stuff, and one of the stuff is that we're working on, or my colleagues are working on, are strawberry production inside the greenhouse as well. And then since we're working on precision agriculture, we're thinking about like, or we have an ongoing project that we sense the needs of each plot or each plant inside the greenhouse, and we're thinking about, because we have 35 I think devices inside, and we're thinking about including ROS to do this as well. Because imagine that you have 35 Arduinos and you want to communicate with them all time to just like measure the water stress and so on, and so it will be much easier using ROS for doing this. And I've been like using this the ROS serial node to communicate with Arduino, so it's really easy to include this. That's just like for part of the static stuff, but the dynamic stuff as the robot navigation, we've already we did this in simulation for the greenhouse, because at the time where we wrote the paper, it was like the greenhouses were dismantled, so we didn't have a chance to try them inside. But now the greenhouses are on, but I don't have time to try it inside, so it's a yeah. So it's a bit like I have like priorities. Mostly the outside navigation seasons we have like a bit better weather than winter, so we're trying to navigate outside most of the time, so take advantage of this. Yeah. That was I'm sorry I took all the time of the meeting that is supposed to be on another subject, but
No,
the time it was on Tuesday, it was a bit early here, 2 or 3 in the morning, so I think it was, yeah.
what's next for you guys? I mean, what's on your priority list?
Now actually we're working on, because when I said like the precision application of the input for the field, of course we will require precision applicator, like precision sprayer. It means like we need, if we have a map and then we need to, for example, apply the nitrogen liquid on specific spots, we will need the sprayer that does this. Conventional sprayers, you just like apply all of it, or boom control. So we had we developed something that it was really basic, using like garden stuff, sprayer like precision sprayer that you can control each nozzle individually. So now what I'm working on is to make this look more, or to make this more robust than just something that is based on like simple garden equipment. So make this like using some T-jet components and so on to make it like more robust and more useful on real sprayer and real tractor. So this is and of course this is including ROS as well, because the idea is, when you have the GPS position of the robot or the tractor, then you can estimate, and you have the heading, then you can estimate the GPS locations of each nozzle. Then we're using a boom of 12 meters, so it's just 24 nozzles. And then like we just like make the matching between the nozzle position and our map. And then if we find, for example, that the nozzle is inside the location of the specific map that needs to be activated with a special amount, or like a specific amount of the liquid, we just like open the thing, and this will be like force autonomous. So the robot just like drives inside the field, and then this sprayer will just like read all the time, like continuously, the position of these nozzles and match them to the predefined map. And the map is created as well, like from other colleagues in my department who are working with UAVs and data collection and similar stuff. So that's the actual.
What's the grid of your map? Is it like 0.5 meter or like decimeter?
It's in meter, but we have like we have really high resolution. It's somehow because not useless, but because the sprayer, when you spray, you have like resolution of half meter. You have the nozzles, and then you have like half meter. But like the maps that we have, the resolution is 4 centimeters. So we have like really high resolution, but yeah, it's fancy. But like when you use it, like on real sprayers, you just like need to adapt it to the sprayer, because we're having like a hyperspectral camera. But now we are developing hybrid drone. I think it's mentioned on the website. So we have now hybrid drone with all different like hyperspectral cameras. And the resolution is a bit lower than what we had previously, but this is what's mostly useful in real field.
Are you using the microsense multi?
No.
Okay.
We were using a camera that is called Ricola camera.
Okay.
And now it's other set of camera. I think the name is Ximia.
That's a great application. I think that weeding application is fun. We have some image data in the perception group, and we've been trying to train a camera to be able to classify weeds versus crops. And we're using the Jetson Nano to try to do that.
Yeah, we're doing mostly the nitrogen level. We try to define the nitrogen level inside the plants. For now, we're not dealing with the weeding, so we just like define the plant's needs in terms of nitrogen. And to do this, it's not an easy task, because like, of course, you need to collect the data. It's not just the data that you collect, but then you will need to have an agronomical model that turns this data that you have into a real useful map for the application purposes. And there are other people or other companies who are doing this based on normal cameras, which is not as precise as this. We're not commercially doing this commercially, but we're a research institute. But we know that there are a lot of flaws in just using normal cameras to detect the stress of the plants. That's why we have like hyperspectral cameras with different bandwidth and then like different stacks and so on, and like an agronomical model that is behind to try to get the most accurate information about the fields and the plants' needs.
And then once you get that data from the model, do you train a neural net?
No. If you get the data, it means, and with the agronomical model, you just get the application map. And if you get the application map, it's a 2D matrix with the matrix with each case has the GPS position, has the rate of what you need to do. So we have models to turn this like from the information that you get from the camera to this application map.
Okay, I heard from Scott Scher at the University of Ohio. He said that nitrogen deficiency starts at the base. And so he's using cameras on a drone with a tether, and he'll fly it into the field and drop the camera down inside and take pictures of the base.
Yeah, this depends on the crop. It also depends on how is because like we've been taking pictures and taking like making data collection for years now, and then we have like a lot of papers published on like the relation between, because what we do as a research station is we have the field trials. And then in these field trials, we go and take pictures by the camera, by the drones, so hyperspectral camera, and then we do the ground truthing. The ground truthing is just like we cut the grass, and then we do the actual nitrogen level, and then we match this to have like the best model that can give us the nitrogen level from the camera. So our models are advanced enough to give us like an accurate information. So that's why like we're not just like going taking pictures and trying to estimate the thing, but we do both the ground truth and then the actual data from the cameras to try to have like the best correspondence between these two.
Okay.
And
Okay.
that's to make sure that your model is giving you like a good, useful information, is that you really know that in this part of the field you have this amount in the real plant, and then of course like you can just make sure that your information is viable of the camera based on this.
So with those heat maps, maybe like a nitrogen map or something, you have 4 centimeter resolution on your maps. Do you store that in like a ROS map layer, or what information, how does ROS see that data?
Yeah, we're not using ROS on the previous generation. Now the new generation that we're working on, because we are developing our own UAVs. Well, we have the frame. For example, we had the DJI S1000 or S2000, but we just like skip all the autopilot and so on, and install like open source like Pixel and so on. And then like we just store the information, like because this Ricola camera has like can have like this drive that are 250 gigabytes or more, because one flight can have up to 10 minutes flights up to 150 gigabytes of information. So yeah, that's that's a lot of information, because like you have several stacks, several layers of the picture of the pixel. It's one pixel but like several layers, because you have different bandwidth. And then like we do like post-processing information on this. So but now the new generation of the drone that we're working on is a hybrid drone. So it's airplane with like 4 rotors, so it can like hover, take off, and then flies. And then with this one, we're including ROS into this, and then the information are just like as ROS packs, and then we do the post processing when we're landing.
Okay.
Yeah. So that's
Awesome.
yeah, that's an overview of what we are working on.
And path planning, and it sounds like you've solved your path planning problem. I mean, are you using a ROS package for path planning?
For the indoor navigation?
No, in the field.
In the field, no. I'm not using any ROS packages. I'm just as I said, I'm using my own code. So it's simple things like you have waypoints as a list. For example, if now when I'm doing the leader follower scheme, I just consider the tractor as a waypoint that is moving at all times, so I don't have a list of waypoints. And then inside this, I just like have my different sensors to get like the position of the robot or the tractor, and then like having defining where what is the distance and the heading from my robot to the waypoint or to the tractor, and just calculating this. And if you have like, for example, different navigation, different points inside, I'm just having like to the, or like a list of waypoints, and then just like injecting this into the controller, and then like read out each time the waypoint, and then having, when you have the distance and the angle between the robot and the waypoint, you just like have simple proportional PID controller just that drives you to the waypoint. So I'm not using any planification or algorithm or so on, because usually when you're inside the field, you don't have predefined maps, because it's an open field. So when you're inside, of course, you have like different landscape and landmarks and so on. But where you're outside and you have like an open field, I don't think it's this useful to use predefined map because usually it's just like an open map. It's blank, so you cannot define the position of your robot based on this is the assumption, because if you have like a specific place where you know your own different landmarks, so of course you can calculate the position of the robot based on this and correct this and use like a planner for doing this. But the assumption is that you don't know the field that you're in, so you just like know the GPS positions and you just like go and follow. So that's why like I don't know its planification, at least for my case, is this useful.
And then Matt, for us, I mean, you mentioned Tab Planner. I've forgotten what you're thinking at the moment on, you know, the mission planning package that we would use.
So we're still doing some work on the global planner, but then move base flex, because we want to drive with dynamic path planning, get from the barn to the field, but then also pre-planned path, so we can pull up a pre-recorded path and then send that into the controller. And then for the local controller.
Sorry, go ahead. My bad.
There's still some work to do around that.
And we talked through Pure Pursuit a number of times. Is Pure Pursuit still intending on being inside of one of those?
But the goal that you need to do is to just like navigate inside the field, like having like lines going up and down, or what do you plan to do inside the field exactly?
I mean, a number of us have different use cases. I mean, someone is involved in row crops. You know, the first use case for me was cutting hay. So again, centimeter level precision, certainly for row crops, would be needed. Cutting hay would be a little less maybe onerous from a requirement standpoint. But I personally have always been trying to have in the back of my head that we were, you know, with RTK GPS, assuming that we have fixed, that we would be able to keep it within a few centimeters, you know, cross-track error.
But how have you dealt with the low-level controller, like the gains and so on, to make it, for example, just follow straight line, like from point A to point B on straight line? Because like I had really big troubles with this to calibrate this, and
I've checked because it's not an easy, not a hard task. I'm chuckling because we've been fighting with it for a year.
I ended up using fuzzy logic system for doing this. It's really more smooth because, well, you need to initialize the functions to know the functions inside. But
what system did you use? Oh, POSIT. I was wondering what system you use for that low-level controller.
I was using like PID controller. Okay. It took really long time to calibrate this. I ended up actually using to calibrate this, I have an drone RC controller for the robot, and then I have potentiometers on the sides. So I just like I have 4 of them, and I just made 3 of them that ROS mode reads this all the time. So I just like tune the PID gains on the go, and then like I just like phase the robot like 60 meters away, and then like make it go on straight line, and then try to adjust this, and it takes really long time. And then like I tried this fuzzy logic system. I tried it before on the drones because when I was doing my PhD, I was working on the drone following ground robot, and I was using this fuzzy logic controller, and it's really useful and powerful tool that is simple, because you can just like imagine that is you are driving the robot, and then like you have the functions of for example, here I have like a small error. Then I don't need to have like big steering. I need to have like only small steering. I have big error. I need to have big steering. And then like you have these functions that are going inside each other. That's why it's called fuzzy. So it's used in a lot of things, used in airplanes and so on. And then like you can see the point, like you have the input that is the, for example, the angle between the robot and the waypoint, and the output is the steering information or the command velocity, the velocity command. And then doing this, like if you can create like good functions for your input and for your output, you will have really smooth smooth navigation scheme for the robot. And has been working quite well actually. I was using a Python package. I can give you the name of the thing. Actually, I was. It's not something that was on ROS, but it's on Python. And since I'm coding on Python, so it was easier to integrate this with ROS. I need to find.
Imagine that. Matt, he asked us if we've done an A/B line run yet.
But you do have like the GPS information and so on. What is the, because I'm sorry, I'm not updated with the current development status of the project. What is the current status?
Well, I know for myself, getting the sensors on the lawn tractor to a point to run that simple A/B test is hopefully, I mean, here in America, we have Thanksgiving. I told Matt it'll probably be Thanksgiving before we run that test, but he said, no, it'll be sooner. So we're hoping to get that done soon.
Yeah. Okay.
This is the test we're trying to run, but we are still working on the hardware down here. Okay.
Yeah. But do you generate, like, do you have special function for the runs, or you generate like the to go around?
Yeah, Dubin's path. So we use I just use Dubin's path, and then you set in the waypoints, and then it will calculate the path for you and the step size, and then
Okay.
send that as a nav path into ROS, and then
Yeah.
use a pure pursuit planner to read in that path and then drive the path.
Okay, yeah. I once actually used the move base. I cheated. Used the move base to create like it was long ago. Trying to navigate inside with like from point A to point B, and then this was before I developed my own navigation algorithm. But since the move base and with the navigation stuff is based on odometry, and I don't have odometry on any of my robots, so what I've done is that I use the move base to create the path, and then like I split the path into small pieces, and then like used like intermediate waypoints, and I ended up like with a list of waypoints, and then like gave these waypoints to the robot, and it was really easy to just like to just follow, instead of like using the whole package completed with the it was a bit complicated for me to set it up. So it just like, I think it can be useful as well, and really easy to put to try if you want to make something simple and running. Just like you have your path, you have like, you can just split the straight line on 2 points, and then like the round on 3 or 4 points, and then this can be useful as well. They just like read the previous and the actual because like it's a waypoint list as well, but it's just like really close to each other. That's what is the path, and this is what I've ended up doing like a few years ago with the move base. Or maybe it's a track that you can try.
And that Python package that you're using, is that like a planner or like a controller? You were searching for one?
Called the C kit. I can send the link for this one. It's just like one of the things that I'm using, and then where is the chat here? So that's the. Have I copied this or not? Yeah, here. Oh, the C kit fuzzy. This was just to create the navigation controller. It takes as an input. It's a function. It's a mathematical function. You have an input, and you have like an output that you need to regulate, and you have the feedback and so on. So it takes, in my case, it takes as an input the angle between the robot and the waypoint. Of course, this angle between the robot is the waypoint is composed of two angles. You have the global heading, and you have the global the heading the bearing between the. We have two headings. One of the robot, so IMU heading or GPS or whatsoever, and then the heading between the robot and the waypoint. So you have two angles, and these two angles, if you make subtraction between these two, you will have like the angle between the robot and your waypoint. So this is the input of the controller of the fuzzy logic system. So you have this as an input, you have functions of the fuzzy logic controller, and then you will need to create the steering command, which is like the velocity command, the angular velocity command. So this is what the package is I'm using it for. So I inject this as an input and output for the steering. As for the distance, because you have two things. So you have the steer angle, you have the distance as well between the waypoint and the robot. And the distance proportional controller was more than sufficient for the distance multiplied by gain, and then when doing the double distance multiplied by gain. So then you can see really like how smooth it is to go to the point. And actually, what I've done is to do this as a visual stuff. I don't know if you've heard about processing.
Yeah.
It's something I've been developed at MIT, I believe. I've been
It's
working
the IDE.
Yeah, it's exactly IDE. So what I've done is I created a user interface that has like it takes like a map, and then I was sending all the time like the position of the robot through UDP to another computer remotely, and then I can see the robot inside the map. And then what I've done as well, it's actually to control the instead of coding each time the waypoint, I just like click on the map and then send the position to the robot, and then I see that the robot is going to this point, and then click to another point and then see the. So this gave me like a quick, simple example, because I could have been using Arvis to do this as well, but I don't know how to include the map in Arvis yet. So like the Jaio map, this was much easier to do this through processing UDP communication and so on. So I just like have a node that listens to the incoming UDP information, and the incoming UDP information is just like latitude, longitude coordinates of a waypoint that you just click on the screen. It was really useful for me to go further or to develop further my controllers and so on. Because like if you have, for example, a robot that is dancing, of course you will see it in real life. You see the robot that is dancing, like to not going straight, and you see it as well, like how big it is, because when you're facing it, you cannot see too much how it's like jumping. And it's really like what is fascinating about this is it's compliant to the theoretical aspects of PID controllers. So you have like an overshot, and you have like and you can see the robot that is doing this, and then like slowly going to the point. And if you change the gains, you see that is changing the behavior and so on. So using processing helped as well to make things more visible and more easier than each time typing a waypoint and different waypoints, or given a list of waypoints and so on. So just like instead of just giving a click and seeing the robot going there.
Awesome, cool work.
Similar path.
Yeah.
I mean, I mean, with the whole, sounds like your next priority around, I'm going to grossly label it the mechanical engineering aspects of getting your spray nozzle.
Yeah, actually, we've done. Today we're working. We're having test bench. That's the. From the camera. Where is the camera? Here, the camera. That's test bench that we are creating. So that's like one arm of the sprayer. And here we have like 20 hertz nozzles, and then yeah, we're trying to, so we hacked the system. We're not using the controller of those who are created or selling the nozzles, but we just used Arduino and so like another drive to make this run in, and then like we changed the frequency and duty cycle of each nozzle and so on to control the rate, and yeah, I was using this with relays, but it's so slow, so you cannot rely on relays because they can stuck and so on. So now we're using other stuff, so it's much quicker. So you can go up to 50 hertz with this nozzles now. So that's a part, because I'm kind of doing the parallel threading on many projects, but this is what I've been working on the last couple of days. But at the same time, like I need to continue on the robot as well for the navigation. But I'm like on the small lawn mowers that you have. How have you handled like the steering? Are you using servos, or is it like because I'm thinking about doing this with the tractor, but the tractor is much bigger and it needs much powerful input for the steering. So I don't know if it's servo is. I don't think it's servo is enough for steering the wheels of the tractor. We thought about using some hydraulics, but how are you doing this with the things that you have?
And generally speaking, on the lawn tractor, we exclusively focused on the DC motor that comes out of a power steering unit in a car. I think 2 or 3 of us have used a Denso motor that came out of a, Matt, where did they come out of? Or did it come out of a Toyota or no, they were Saturn Vue, a US car called a Saturn Vue. About a $70 or $80 item, depending on where you got it. We were getting ours off of eBay. That would have been driven by a motor, a DC motor controller, and a couple of us have used the Teensy microcontroller to drive that motor controller. On the angle sensor for the steering, we've got 2 or 3, we've got 3 different approaches going on. Matt's got a multi-turn potentiometer. I think, Jeff, are you using the quadrature thing on your steering? I've forgotten what you're using on your steering angle sensor.
At the moment, I'm using that super servo. So it's like a giant RC servo. So I tell it the angle to go to, but I can solder a wire inside to get the position back out. Yeah. So my steering is done differently than what they're doing.
And then I'm trying to get the magnetic rotational sensor working. It's made by a company called AMS. So we've got slightly different approaches, but on the motor itself, given that there's not power steering in the tractors that we're talking about, we needed something it's effectively a worm gear, and it's a high torque device. I can tell you on my John Deere tractor, which did have power steering, I was able to use a much smaller DC motor to spin the steering wheel, and had a potentiometer out on the axle to give me an angle sensor to react to. So, I mean, we've got a few different approaches to solving some similar problems that you've tackled. I will tell you a person who's a part of the team, Kyler Laird, who you'll see a lot of YouTube videos that he's done. He's a huge proponent of the hydraulic solution. And again, if you've got capability in that space, I'm channeling him into the conversation, but I think he would be promoting the hydraulic control.
Yeah. What about throttle? Like
what about what?
The throttle, the gas pedal.
Yeah, I know on my John Deere tractor, I hadn't tackled the throttle yet. It was going to set it and forget it, to get started, because getting steering organized was more of a challenge. On the lawn tractor, transmission, there's two components when you say throttle, but for speed, the lawn tractor has a hydrostatic transmission. So there's a servo. If you Googled it, you would find a Super Servo 200 or Super Servo 500 on eBay. Matt and I are using those to control the hydrostatic transmission, and then the actual gas throttle to the engine. Again, I don't know, Matt, if you've ever gotten yours under servo control. I was set it and forget it at the moment to do testing, so I don't personally have mine under digital control yet. Matt, anything to add to any of that?
No, that's great. Yeah, it depends on your budget, but electric over hydraulic, probably the most robust and easiest built into the tractor. And then second would be the electric power steering.
It's not a Ross implementation, but there's another group of folks with a system called Ag Open GPS, I think, Ag Open GPS. And they've got information about their steering control too, at least the mechanical engineering side of that. Some are using hydraulics, some are using, high-speed DC motors. Again, with the assumption that on the DC motors that the tractor's already under power steering control. But we're definitely, the challenges that you've had and solved, I mean, some of us have solved some of those as well. Some of those in your future we have to fix as well. So we're definitely in the same space. It would be nice to stay in touch somehow and keep working together.
Sure, that's for sure.
I think Matt saw the picture of your environment there, and he's like, after he leaves Argentina, he's going to come to Oslo.
Yeah, you're most welcome if you want to visit us one day. It's really, really lovely place. I'll be most happy to host you. So
Very cool.
What do you think, Matt? Better hurry though. It's going to get cold up there.
I'll bring my skis. It'll be okay. We can go skiing.
yeah, we're not far from the places, so it's just like 40 minutes drive. So
I'm thinking Texas in February, Oslo in April, Lafayette in June for planting. Get the whole year planned out.
So I just posted a link to the chat window, and it's the videos that go along with that Ag Open GPS. The guy that developed the whole thing has made a lot of really good instructional videos and explains how to do a lot of this stuff. So you can dig through that. He's got lots of stuff to keep you busy on that.
Yeah, when it comes to mechanical engineering stuff, I mean, the problems are exactly the same.
yeah, that's for sure. There is a group actually in the UK. I don't know if you've heard about it. They had a product that is called what is called 1 hectare or something. They have like an area that they try to have like no human going inside the field, like only tractors and so on. So they've been going through this. There is automation of the tractors and so on. Not only tractors, but yeah, everything that is used from planting to harvesting. I can try to.
I have seen that. I was trying to remember whether they were really open source or not. Certainly, I saw their website.
I think that's called hands-free hectare is what that's called.
Yeah, exactly. Yeah, press release. I'm here on it, and I think now they've extended this to more than one hectare. It was 1 hectare before, but now I think it's extended. My boss is in touch with this guys as well. So we thought about paying them a visit, just take a look, and yeah, can be interesting. There was like an EU project as well, going around the same, almost the same aspect. Quite a lot going on in this field. But what is unfortunate is that not a lot of people are sharing online, their experiences, and like yeah. So that's why it was interesting to join the group and start to share some experiences, some codes, and so on and so on.
Speaking of, have you learned any? I mean, our sharing platform is a combination of some things out on GitHub, Google Drive, certainly these videos and YouTube. I mean, can you just comment about how you have approached the notion of, trying to share or communicate any things that you've want to try to share?
Testing stage. We want to make sure that what I'm going to share is working well, to make it public. But if somebody is interested in a piece that want to try at his own risk, I will be willing to do this, not a problem. So it's to do this publicly. We're not this advanced yet, at least in the outdoor part. So we have so it's not a problem if we're, for example, having the GPS heading or whatsoever other nodes that we can discuss and share the codes. It would be like useful for us to have feedback on what we're doing, and of course getting some help if we're stuck in something. So.
Okay. Well, I've got a quarter past the hour, and although I'd be happy to stay on, I'm just trying to be respectful of you guys' time. Matt, anything else from your perspective?
Awesome. Thanks for the presentation. It was great meeting you.
It was great meeting you, all of you, really.
Sohin, anything?
And,
I'm sorry, go ahead.
No, I think I will try to be present at this, at least the Friday's meeting. So the other time is a bit early, but this one is just perfect because the end of the weekend, home. So it's quite good. And I don't know if you have like schedule for the points to discuss for the next meetings, or I don't know how it functions actually. I've tried to go through the messages and so on, but it was a bit like complicated to get track of what have been going on, how you do things here. So you usually like have meeting points that you try to discuss, for example, the next meeting or the current meeting, or just like have updates on the ongoing project.
Yeah, I would say we're organic, but I don't even think we're as organized as an organic organism. Generally, we share what's going on with our individual projects and sort of where we're at and what are some of the challenges that we're faced with, and people generally then contribute with, you can try this or you can try that. So it's largely around project updates, what we've been working on, what are some of the challenges, and then others try to help each other through some of those challenges.
Okay.
I had one last question before.
Go ahead.
Before you leave, Chouaib, do you have? So, is there a camera on the robot that was following, or does it have a LiDAR for obstacles, or how does that work? Is it just a follower, or is it also aware of obstacles?
It depends on which video we're talking about. If it's the video of the winter, so it's just a camera,
and we have of course the LiDAR just. Yeah, with the snow, or no, the latest one. Yes.
Okay, I've shown 3 videos. One of the indoor small robot and 2 for the big robot. You're talking about the small one?
I'm talking about the big robot, the one that was following the tractor with a beautiful view on the other side.
Okay.
That was in winter.
These were 2 videos. One was with the snow, one was without the snow. The one that was
without the snow.
without snow, I'm not using the camera. I'm just like communication based. So I'm just subscribing on the topics of the tractor, and then getting this as like an input, like a dynamic waypoint, instead of, because usually like you just like give a waypoint and then the robot follows. But now it's like I'm using it as a dynamic waypoint, so it just like try to correct itself all the time. So that's what I'm using. I'm not based on cameras at all. So it's just like purely communication based.
Right. Yeah, that's right. That was the question. Thank you so much.
You're welcome.
So, and while you have the floor, anything else that you wanted to mention or share?
No, I've been looking at performance upgrades on stuff that I'm working on, looking at multi-threading and stuff. It's exciting.
On what platform?
C++.
But hardware, what platform? On
I'm just working on coverage planning for now. So
cool.
on the Sabanto robot basically, but it should be it's applicable to any robot. Also, I shared a coverage path planner that's open source from ETH Zurich, and you'll find it around 12:50 p.m. Eastern time on the chat. But that's the answer to the global planning talk that we had earlier in this meeting. It solves our problem, honestly, in terms of global planning. And then we can find out, once we have the waypoints, we can just create the Dubin's path and have it follow it. So, Matt, if you have a chance, or anyone, if you have a chance, just take a look at that. I think it's pretty neat.
Cool, thank you, Sohin. Jeff, anything as we wrap up?
No, I don't have anything.
Okay, guys, we'll have a great weekend. Chouaib has got a little bit of a head start on us there, so
Yeah.
you might find him down at the at local eatery, you know, already starting on early dinner. So, guys, we'll talk to you next week. Have a great weekend.
Thank you very much. See you.